Okay, so we're back looking at this problem where it says how many distinguishable 11-letter words can be formed using the letters MISS, ISS, IPPI. And so this is a formula that we have when we have the number of distinguishable permutations of n objects of r different types where you have some of them are identical. So when you look back at the word Mississippi, the S's are identical. You have 4 S's, you have 1 M, you have 4 I's, and you have 2 P's. So what this formula is telling you to do is to take the number of objects, which in this case was 11 factorial, and you divide by the number of letters that are repeating factorial. So for example, since you have 4 S's, you're going to divide by 4 factorial, and you had 4 I's, so you'll have another 4 factorial. And then you had 2 P's, so you had 2 factorial, and then you just have times 1. So we can clean this up. This is kind of messy. You can clean it up right here. You can type it in. If you have a graphing calculator, you can just type it in just like you see, as long as you put these parentheses around the denominator. Otherwise, if you want to do it by hand, you can write 11 factorial, and I'll redo this so that it makes sense. 11 factorial is 11 times 10 times 9 times 8 times 7 times 6 times 5 times, I'm going to stop at 4 factorial so that I can cancel a 4 factorial in the denominator, and then I'll rewrite these and then show the, I'm going to cancel that 1 4 factorial, and then I'll write this 4 as 4 times 2, 3 times 2 times 1. And I'll write the 2 factorial as 2 times 1, and then I still have the 1. Okay, so this 4 factorial cancels with that. And then you can just do a process of reducing. So 4 goes into 8 2 times, 3 goes into 6 2 times, and the 2 can cancel with that 2, and this 2 can cancel with that 2. So you end up having just 11 times 10 times 9 times 7 times 5. So 11 times 10 times 9 times 7 times 5, which is 34,650. Is this right?
Yes.
Yes.
Good. All right, so 34,650. I don't know if it's right, but I just spent a lot of time talking about it.
I know.
Y'all are like, and see, you don't want to miss this one because you only get 7 questions. So that's 5 points.
7 questions?
I mean, I don't know, 7. Where did 7 come from? I don't even know.
Because we were on numbers. Oh,
It's
no.
the next
I don't know.
I don't even know where 7 came from. You only get 20 questions, so that means they're 5 points each. Right? Okay. I'm slightly nervous that I missed that one. Should I be?
No.
No, doesn't matter. I don't need a grade. All right, determine whether the following problem involves a permutation or a combination. A medical researcher needs 20 people to test the effectiveness of an experimental drug. If 77 people have volunteered for the test, in how many ways can 20 people be selected? All right, Ridge, combination or permutation?
Combination.
Very nice. Why?
Just because I got lucky.
Order doesn't matter.
Oh, the order doesn't matter. That's the answer.
Right, because if we just had Clyde and Christina and Ridge testing out the drug, it would be the same as Christina, Ridge, and Clyde, right? So that's a combination when order doesn't matter. Okay. Determine whether the following problem involves a permutation or a combination. How many 5-letter passwords can be formed from the letters Q, R, S, T, U, V, and W if no repetition of letters is allowed? Okay, let's have Matt tell us.
Permutation.
Very good. Why?
because there's an order, right, or anything like that?
Right, yeah, like QRSTUVW, that password would be different than, or I mean, how many letters are that? We can only pick 5. So I guess QRSTU is a different password than UTSRQ, even though they're using the same 5 letters, right? So since order matters, it's a permutation. Very good. All right. Use the formula NCR to evaluate the given expression. So you have lots of ways that you can work this. If you have the graphing calculator, you can type it right in with the graphing calculator. I'm going to assume you don't have the graphing calculator, where I would like to see you use your Google spreadsheet. So if you did a Google spreadsheet, you would want to put, your N here would be 7. Your R would be 4. Remember the permutation, I just did equals and I typed the word permute and grabbed the formula, and then I did E3 comma E4. For combinations, you do equals, combination, and then E3 comma E4. But either way, you get 35. Shay, do you want to do this one by hand?
Sure.
Such enthusiasm. How do you do it by hand?
I think is it 7 factorial? Or is that a lie?
Yeah, so let's see if we could do N. It's N choose R, right? So it's N factorial over N minus R factorial times R factorial. That's the big formula for a combination.
Right.
And so what was this one? 7 choose 4?
Yes.
So we'll do 7 factorial over 7 minus 4 factorial times the 4 factorial. So this is 7 factorial over, that's 3 factorial times 4 factorial. So this is, or I was supposed to let you do it. Help me.
You can do 7 times 6 times 5, and then times 4 factorial, and then over 3 factorial times 4 factorial, and then, no, okay, just kidding, you cross out the 4 factorial. She's doing it, so.
I like what you're doing. And then under 3 factorial, I wrote it 3 times 2 times 1.
Okay.
So the 2 goes into 6 3 times, and then 3 goes into 3 1 time. So it's 7 times 6, which is 35, right?
Times 5.
Is that right? Is that what you got with your calculator?
Yes.
Yeah.
Yeah, and that's what we got here too with the Google spreadsheet. Okay, so you should be able to get this one. That's a kind of a gimme problem, isn't it?
Yeah.
Thank you.
Make it work. Okay. An election ballot asks voters to select 2 city commissioners from a group of 6 candidates. In how many ways can this be done? So, I haven't picked on Stephanie at all, have I?
No.
Poor Stephanie. I'm sorry. Would you call this a combination or a permutation, Stephanie?
Permutation?
If it's a permutation, order would matter. So if there's 6 people in that room, and if we pick 2 to be on a committee, I don't think it would matter. Like if Shay and Ridge got selected, or Ridge and Shay, the order wouldn't matter. Does that make sense?
Yeah.
So that's actually going to be a combination. Okay. So do you know how would you do that combination? How are you doing these combinations?
In Google spreadsheet.
You are? Oh, good. Easy enough.
Answer.
Pardon?
Google spreadsheet is always the answer.
Oh, good. Yeah, just to make me happy. All right, so you put, what are you going to put in for N?
6.
Good. And then what are you going to put in for R?
2.
Very good. And then be sure to pick the combination one, which is 15. Does anybody want to see it done by hand?
No.
No.
All right, how about Matt? Do you want to see it by hand?
It doesn't matter. Go ahead, move forward.
Are you sure? Because I remember you were struggling with this a little bit.
Yeah, I think you do what this, what were the numbers again?
62.
Yeah, do it five,
62,
do it
so
five.
6 factorial over, 6 minus 2 factorial, whatever.
Yeah. Let me get.
And then you would do the, yeah, you do the order and multiply them.
All right, so I'll make this a 6 and make this a 2. So 6 factorial over 6 minus 2 factorial times 2 factorial. So this is 6 factorial over 4 factorial times 2. So I just kind of start going down until I get to 4 factorial. Cancel the 4 factorials. And this is 2 times 1, right?
Goes into 6.
Yeah. And so I do get 15. Make sense?
Oh, yeah.
Is that what we got with the Google spreadsheet? Yes. Okay, good. Okay, to win at Lotto in one state, one must correctly select 7 numbers from a collection of 47 numbers. The order in which the selection is made does not matter. How many different selections are possible? So, Ridge, is this a combination or a permutation?
Here you go. It'll be a permutation, right? Oh, no, it's a combination, I'm sorry. Never mind, I don't know.
Do you ever play the lottery?
No?
No, good. That's good.
It says the order of selection does not matter, so
Oh, okay.
it's
then it is
combination.
combination.
Yeah, and if you think about in the lottery, you know, like if you have 30, well, I could say, you know, you pick the numbers and they can switch them up and it's still, you're still a winning ticket. So the order doesn't matter. So we're going to do 47, choose 7. And I'm just going to use the Google spreadsheet because I'm being lazy. All right, so I'll put 47 in here, choose 7. Is anybody using the website? Because you could also do the website if you wanted. Do you need to see me do that, or you feel like you're okay? Did Gayla, did you get, or Christina, did you get?
62,891,499.
What?
Yeah, me too. Okay, 62,800,000 and what?
891,499.
You got one too many 9s in there. It's 891.
Yeah, it's 8, not, yeah, 8, 9. You got one of those 9s.
Okay, so what do you do?
You like that better?
That looks good.
What? Okay, I'm confused. What do you do on this one?
It's gonna be the 47 and the C and the 7. It's not permutation.
I'm sorry,
Combination.
I'm in factorial.
The 47, the,
Combination.
And then,
And then the 7.
Do you want me to show it by hand?
which would be 49 factorial divided by,
yeah.
okay,
Or 47 factorial?
well, I'm sorry.
Yeah, divided by 45 factorial times, was it, or however many it was.
47.
Do you want to see it by hand?
No.
No.
All right, I won't do it by hand. I don't want to, I want y'all to make 100 on this test. Okay. In how many ways can a committee of 4 men and 4 women be formed from a group of 12 men and 10 women? Okay. So we want to have 4 men and 4 women from a group of 12 men and 10 women. Does anybody remember how to do this problem?
I have my notes right here in front of me.
Okay. What do you remember about it?
It says how many ways can 4 be, well, that's the other one, the homework one, or the, yeah, 4, 4.
Yeah.
It says how many ways can, 4 be selected from the group of 12? So it would have been 4 combination, or 12 combination 4. And then to choose 4 women from the 5 women would be 5 combination 4. And then the probability was 5, which is what you got for the women, and then over or divided by the 495, which was the total of the first wave. So
Okay, so that's actually a little bit different problem, I think. In this one, because we don't have probability yet. So we want a committee of 4 men and 4 women. So the first thing we need to figure out is of the men, we need to pick 4 men, right? So how will we do that? There are 12 men in the group. So we should do 12 choose 4. Let me see how I can get this to write it.
12 choose 4 is 495.
it's the same.
So we'll do the men will be 12 choose 4. And then what's the women?
10 choose 4.
10 choose 4. And then the way that we can figure out the number of ways of our committee is we'll have the number of ways that we can get 4 men times the number of ways we can get 4 women. Okay, so 12 choose 4 is
Can you slide the one that you're working on down a little bit so I can read the question, please?
how's that?
Oh, okay, I was just trying to see where, I thought, for some reason, I thought it was 4 women at the top. It is.
It's 10 women.
4 men, right, but I put down a different number, that's all. I put down 2.
Okay.
I said 10, I don't know why. Thank you.
Is everybody okay?
Yep.
Okay, now 12 choose 4. What did you get?
495.
495?
Yes.
Is that what you got, Clyde?
Hold on. Yeah, 495 on the first one and 210 on the second one.
And then 10 choose 4 is how many?
210.
Did anybody else confirm that number?
Yes.
Yes.
Okay. And then now I want you to multiply those 2 numbers together and we'll look for a confirmation.
$103,950.
103,950?
Yeah.
Anyone else?
That's what I got.
Okay. So that's what we're going to go for. Does anybody need time to write that problem down, or you got it?
Got it.
Matt?
You just go ahead. Okay. No, I just need to.
Oh, it's back.
Pardon?
I got it now.
Are you sure?
Uh-huh.
Okay. Brody, you're right.
Brody's not here.
Brody's not here?
Oh, Brody. I mean, Ridge.
Yeah.
He's all right. Stephanie's okay?
Yeah.
All right. All right. So let's go to the next question. You're dealt 1 card from a standard 52 card deck. Find the probability of being dealt a club. Okay. Who remembers how many clubs there are in a standard 52 card deck?
13.
Good, 13. So it's going to be 13 out of 52, but you're going to need to reduce that. So how many times does 13 go into 52?
4 times.
Right. So it's a 1 out of 4. Do y'all want to see see something written down there, or is that okay?
Hold on.
So,
On that one, remember, there's 52 cards and 13 suits, right?
No, 4 suits, and there's 13 in each suit.
Thank you. You know what I mean.
right. So you have 13 clubs,
Oh, okay.
13 spades, 13 diamonds,
Fours.
and 13 hearts. And so the total number is the denominator, which is the 52 cards. And in this case, they want the probability of being dealt a club. And so you just say how many clubs there are, which is 13. But the problem is you have to reduce your fraction. 13 is a prime number, but 52 is actually goes into 13 4 times. 4 times 13 is 52. So your 13s cancel, and you do get 1/4. You can also go to that calculator soup, and it'll do the fraction reducer thing. Are we all okay?
Yes, it's just Gayla keeps writing on her notes from the notes that she took from the notes in class, and
Because I
she's
want to
going to confuse herself.
I want to be prepared.
So I'm trying to tell her to quit writing.
All right. A fair coin is tossed 2 times in succession. The set of equally likely outcomes is head, 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 tail, tail, head, tail, tail. Find the probability of getting exactly 1 head. Okay, exactly 1 head happened in the head tail, and it happens in the tail head. Do y'all see that?
Yes.
So the total is 4, so that's your denominator, and the numerator is 2. So it's 2 out of 4, which reduces to 1/2. Everybody okay?
Yep.
Okay. 17. Use the spinner shown to answer the question. Assume that it is equally probable that the pointer will land on any one of the colored regions. If the pointer lands on a borderline, spin again. If the spinner is spun once, find the probability that the pointer lands in a region that is brown or blue. Okay, so you need to figure out how many regions you have. So how many regions do we have there, Ridge?
Wait, we don't see a
Yeah, we don't see a spinner.
Oh, you got it. Can somebody go up and do the fit to window thing on the computer screen? You know what I'm talking about?
Yeah, Stephanie's going up there.
Okay.
Now it goes to the more. Like go to the more right there, Stephanie.
Where? Oh.
Yeah. Now yeah, there you go.
Okay.
So how many, what's our denominator?
10.
10, right.
Yeah.
And then now, how many ways is it that it could land on brown or blue?
5.
Yeah.
3.
Brown or blue?
Wait,
Oh, brown or blue, 5.
That's 5.
Yeah. So it's going to be, the fraction's going to be 5 out of 10, but we want to reduce 5 out of 10. Can y'all reduce 5 out of 10? Good. All right, good. Almost done. Sergio, Sarah, Larry, and Jim have all been invited to a dinner party. They arrive randomly, and each person arrives at a different time. In how many ways can they arrive? So is that a permutation or a combination?
Combination, right?
Permutation.
Well, the order matters, right? First, second, third. So how they came matters. So it's actually a permutation. So in how many ways they can arrive, you have some options on how you work this. But what we can do here is we can do, how many people are there? Sergio, Sarah, Larry, and Jim. So there's 4 people. So that's like 4 slots. And so you would do 4 for the first person, and then 3, and then 2, and then 1. So 24 ways that they could arrive. Does that make sense?
Yes.
Okay. Now it says, in how many ways can Sergio arrive first and Jim arrive last? Okay. So now we want Sergio to be first and Jim to be last. So the first and the last already are assigned. So how many people do you have available for coming second?
2.
Only 2. And then you only have 1 left to be third, right? So this answer is going to be 2. And then it says, find the probability that Sergio will arrive first and Jim last. Who's got an idea on how to find that probability?
One in the first slot and one in the last slot, and that would leave you 3, 2, 1 for the middle one, correct?
Well, no,
Divide
there's only,
2 over 24, right?
well, right, Clyde, there's only 4 people total. So if you have one in the first and one in the last, then you only have 2 people left for the middle.
So that'd be 4 times 3.
No, what?
All right, in your slot, you'd have 1 and then 4, and no, you'd only have 3 and then 2, wouldn't you?
No, you
Well,
only
see-
have 2 and 1.
Because you got the first person has to be Sergio and then Jim. So all you have left is Sarah and Larry, and then you'll only have either Sarah or Larry left.
So it'd be just 1, 2, 1, 1.
Yes.
That'd be the same as the answer B.
Well, no, now on C, they want the probability. So you're going to take that, yes, you're going to take your answer from part B and divide it by your answer from part A, because that's all the different ways that they can arrive. So the probability is going to be 2 out of 24, which reduces to 1/12. Everybody okay with that?
Yep.
All right. So I'll put in 24 for A, and then B is 2, and then C is 1 divided by 12. Everybody okay?
Yep.
All right. A group consists of 4 men and 6 women. 4 people are selected to attend a conference. This sounds like the one that Christina was talking about earlier. In how many ways can 4 people be selected from this group of 10? Okay, so Matt, combination or permutation?
This would be combination, right?
Yes, you're correct. Very good. And that is because you're just picking people, right?
Yeah.
Can y'all hear my dog barking?
Yes, I hear him.
I'm sorry. I tried to put him away. I knew he was going to bark because you know who's here at our house right now?
The snowman.
The snow plow guy.
Oh.
Isn't that horrible? It'll make you mad, but because there's snow all over the road. All right. So 4 people from 10. Okay, so this is 10 choose 4. So if we do this old school, it's 10 factorial over 10 minus 4 factorial times 4 factorial, right? So 10 times 9 times 8 times 7 times 6 factorial. This is 6 factorial, and this is 4 times 3 times 2 times 1.
And then divided the 2 to get the probability. 210. So you just do combination for each, and then find the probability by dividing the 2.
Y'all get 210?
Yeah. No,
Okay.
because 4 plus
Yes?
6 is 10, so it's going to be 10, and they're trying to find the probability.
Are you working ahead?
4 people can be selected from the
I'm
group
not
of 10.
sure.
Right.
Hey, did y'all get 210 for part A?
Yes.
Okay. All right, now let's go to part B. It says the number of ways to select 4 women from the group of 6 women. All right, part B. 4 women from the group of 6 women, that's just going to be 6 choose 4, right? That's going to be 6 factorial over 6 minus 4 factorial times 4 factorial. So that's 6 times 5 times 4 factorial divided by, that'll be 2 times 1 times 4 factorial. So I think I'm getting 15. Did y'all get 15?
Yeah.
Yep.
Okay. Now, part B, find the probability that the select group will consist of all women. So we're going to do 15 divided by 210, right?
Yep.
And now you have to reduce that. And you can think of 15 as 3 times 5. And you can think of 210 as 3 times 7 times 2 times 5 if you want. Then your 3's cancel, your 5's cancel. You should get 1/14.
Yep.
Okay? So we have 210, 15, and 1/14.
Yep.
Christina. All right, 210. What was the next one? 15?
Yep.
And then what was this? 1/14?
Yes.
What is it? Is it a movie or something you're reminding me of when you go, yep?
Yeah, that's the Storage Wars of that one guy.
Oh,
like,
that's right. How funny. Okay. A box contains 15 transvestors.
Oh.
Transistors. 3 of which are defective. If 3 are selected at random, find the probability that all are defective and none are defective. Okay, so the first thing you have to figure out here is your denominator, okay? Let's start by figuring out what our denominator is going to be. You've got 15 transistors and you're going to select 3, okay, guys? So let's figure out how many ways we can do that. Is that a combination or a permutation?
Combination.
Good. Okay, so we're going to do 15 choose 3. And so that's 15 factorial over 12 factorial times 3 factorial. So 15 times 14 times 13 times 12 factorial by 12 factorial times 3 times 2 times 1. So those cancel. This goes in 5 times. This goes in 7 times. So 35 times 13, which is did y'all get 455?
Yes.
Okay. All right, so 455, that's your denominator. Now, we have to figure out how many ways that they'll be all are defective. And you might actually be able to reason this one out without doing any combinations. But 3 are defective and you have to pick 3. So how many ways will that happen? Pardon?
Did you say 3, 9? Is it 9?
Well, 3 are defective and you have to select 3.
So it's just 1.
Yeah, because there's only one way for that to happen. 3 choose 3. But if you do 3 choose 3 on your it'll be 0 factorial over 3 factorial. Remember, 0 factorial is 1. So this does just work out to be 1. So part A, the probability that they're all defective is 1 out of 455. Does that make sense?
Yes.
Now, the probability that none are defective, how many not defective are there?
12.
Good. So you're going to do 12 choose 3 to figure out how many different combinations of the 12 non-defective you could get if you take 3 of them. So that's going to be 12 factorial over 12 minus 3 is 9. 9 factorial times 3 factorial. So this is 12 times 11 times 10 times 9 factorial. The 9 factorial will cancel. This is 3 times 2 times 1. So 3 goes into 12 4 times, and 2 goes into 10 5 times. So that is 20 times 11, which is what?
20 times 11 is 220, right?
220, right?
Yes.
So the probability that none are defective is equal to 220 divided by 455. And you're going to need to, you have to reduce that. Okay? So you have some options. You can use your math frac button or you can do it by hand. Like 5 goes into 220. Let's see, that's going to be 44 times, right? Yeah. And 5 goes into 455 91 times. And then, is that it? Did y'all try the math frac? Does it reduce any more than that?
No,
44.
44 over 91.
No, just 44 over 91. You're right.
Okay, so we got 1 out of 455 and then 44 out of 91.
Yep.
So when I have to check it, I hope I got this right.
Awesome.
Okay, if I missed any of them, don't worry about it. Well, I'll make a video if y'all care for later. Hopefully it's 100. You ready?
Yep.
Do y'all normally pray or anything, or you just hit submit test?
Just say something.
Just submit.
Did it hurt? Oh yeah.
Oh, yeah.
That's good.
Yay for us.
That's
Thanks,
fantastic.